Great. Well, good morning or good afternoon if you're over in the US or Canada. Welcome to this webinar, which has been hosted by the Australian Controlled Traffic Farming Association. So my name's Bindi Isbista. I'm the chair of ACTFA for the next half an hour, maybe, or more. And we'd just like to take this opportunity this morning to share with you our project that's funded by GRDC on farm operations optimisation that's led by Verge. And I'd like to welcome Goddard and Nick here from Verge today, who we're working with to deliver this project, which I think is a very exciting project. And we've got a great team of people working for us through ACTFA with consultants and growers around Australia. And I think it's also highlighted the international nature of the topic that we work on, which is exciting. So this morning, we're just going to have a presentation for 30 minutes before, followed by the AGM. For those of you that would like to stay on and join the AGM, it'll be a short AGM, I promise. So now I'd like to hand it over to Nick, who's going to share with you a bit of information about the project and Launchpad, which is the tool that Verge is developing, and how it can help optimise operations efficiency and some of those opportunities. Thanks, Nick.
Thank you. Well, I'm going to do a bit of a demonstration of our product Launchpad, which is kind of part of the on-farm optimization. So we're working with Bindi and other people with ACTFA to kind of understand grower problems as it relates to in-field equipment movement, equipment selection, etc. And so I want to take you through just a tour of what Launchpad does. And then feel free to ask any questions. I think, Bindi, we're going to reserve a little bit of time for questions at the end as well.
Yep.
Everybody see my screen?
Yep.
Wonderful. So a couple of sample fields here that I hand drew in Western Australia. And so the focus of Launchpad is really to remove in-field decisions. So today, when we interview growers, what we tend to hear is, when are you going to plan? When do you decide how it is that you're going to do a particular thing within your field? And a lot of the times it's on the way to the paddock or when I get to the edge. And as we're seeing farm consolidation, et cetera, the need for pre-planning, the need to understand exactly what I'm going to do is growing in nature. So one of the things that we're looking at doing is solving some of those problems ahead of time. So how can we plan the equipment movement within that field? Sorry, I'll say paddock. I'm pretty good at that. I'm metric qualified now. But how do I pre-plan? How do I make all those decisions ahead of time that I can make? Because there are a lot of decisions that you can make ahead of time. And it just so happens that tractor technology allows you to do it at the field's edge, but you don't actually have to. And that becomes especially important when you get larger, when you have non-family staff, etc. So just quick run through here on, so I chose this paddock in Western Australia. This is effectively kind of farmed with as one piece within here. And one of the things that we can do is decompose that field into smaller pieces. So, nobody's going to farm that north and south. So effectively, there's two patterns within that field, the right side and this top left side. So that's one aspect that we do is be able to split that field up and decompose it. And what I'll do is I'll just create a quick path plan for you right now. We'll use an 18-meter cedar, 2 headland passes, and I'm going to turn slopes on so that we can look at that in a bit. And so what we're going to do when we run this is we're going to take a look at this field boundary. Each part, there's 2 parts of those. We're going to build headland passes around them, and then we're going to build tracks where we want to maximize coverage of that entire field. So this is a path plan right now of this field. You don't often see this. You typically only see this when they're in the cab of a vehicle and the monitor is showing where, based on what inputs you've done. You kind of see something like this in as applied data after the fact. But we're really the first that has started looking at pre-planning this in a web environment. So here over to our left is our heading direction. And the first things that we do is we just calculate the straight edges. We look for the line of best fit along this. And we say, hey, what's basically the straight edge? And we automatically align to that longest, straightest edge. And we give the option of a couple other ones. This is kind of an interesting paddock on how it's shaped. But we give the user a way to graphically kind of play around and say, what's interesting about this. We also have some calculated patterns. So the longest edge, the least number of tracks, shortest distance. And you notice this is it's not a terribly irregular paddock. So some of those are the same, but as you get more and more irregular, more internal obstacles, different speeds, whether you're turning or working, non-working, you'll start to see different solutions depending on what it is that you want to achieve. Far and away, that longest, straightest edge tends to be the way people pick, and it tends to be pretty reasonable on how they want to farm that paddock. Field summary. So we summarize all of this information as well. So how many tracks there are, what is that distance, what are all the critical parameters of that field. So for each one of those, kind of call those results, potential solutions, we calculate all of that information to better understand, allow growers and farm managers to better make decisions. And in this case, we do that for the entire paddock, but we can actually look at individual parts. So I might want to just look at part 2 here. So I only have 2 tracks in that little tiny part. So you can imagine if I had a much bigger paddock, I want to look at each individual part, and I want to be able to summarize that across the entire paddock as well. I want to turn on a layer here for you. We calculate and create a coverage layer. So this is another thing that I don't think you see anywhere outside of after the fact. So coverage is in that purple. Where we have overlap is in that dark purple. So we're showing overlap prior to the vehicle even going through that paddock. And let's just pop over to this one. You can kind of see if I align to this top edge, I move my overlap over here. If I move my overlap up here. So depending on the width, depending on your paddock size, you may want to shift overlap from one side of the paddock to the other side. In this case, this is really about what direction you want to take. So we're not taking into account section control at this point. But at the end of my presentation, I have some comparison tools that I'll talk about where I really truly take section control into account in how that technology helps growers. So I did turn on the slope layer when I started, and I want to pop that on again. So while we were, let me turn off coverage. So while that was processing, we were actually going out and grabbing some digital elevation models. We use a source from NASA DEM, which is a 30 meter postings. It's pretty coarse, but we like that because it's available worldwide, and we wanted anyone in the world to be able to look at slope. So what we did is, for your track direction, we calculated the slope every 30 meters. So where you see dark green, the vehicle is more or less flat. Where you say red, it's at a high grade. We don't show the directionality of that case, of that. And but what we've done though is we've calculated that for every heading, and we can actually minimize that soil loss potential. Oops. So given the terrain of this, now, not saying that anybody would do this because you'd be trading off efficiencies and other things. But this would be the heading that would minimize the potential for real erosion loss. And that's really based on the slope and the length. So it's steepness of that slope and the length of that slope for that water to get rolling down that hill. Where we see this around the world, in a lot of cases, is where you don't want to do curved paths around high terrain, but you have row control technology and no-till, and you can keep the same soil loss as you might with curved paths and terraces. So here where I live, we have terraces built in the 50s. They don't match our machinery anymore. The Suns are wanting to tear them all out. And then our regulatory authority is starting to say, okay, yes, what management practice changes are you going to make to be able to pull those terraces out? And this is one of those examples. So I could farm something at this particular angle and keep the same soil abatement as I would with terraces. And because I have row control, section control technology, I'm not taking as big of a hit on overlap or on overlap, so product loss, etc. So it kind of works. So they're simplifying their field operation, getting rid of curved paths, getting rid of terraces, and going to something like this. So this is where we do a little bit of a terrain analysis. And then we also kind of show, so basically 40% of that field is in zero, basically 0 to 1% slope for this particular heading, and we're less than 1% or less than 2% is at is a high slope area. So we do that analysis across the entire field, and we can do that for any pattern. So if there's a curved pattern, if there's this straight pattern, we can really look at what is the slope of that vehicle is taking across the paddock. So one thing, one of the things that we got from our Australian customers, and this is something that we knew, was, but like, hey, I'm not going to change my run lines. I've been in CTF for 20 years. Not going to happen, right? So one of the things that we've done is we've allowed the user to be able to enter in their run lines that they have been using. And this is an area where I have to actually hand enter all of these. We will get this automated. We will be able to pull this from their monitors and their My John Deere accounts, etc. eventually, but I have to hand enter it for today. So in this case, this is the AB line that they use for the entire farm. So every field would be farmed using this AB line. And I want to build a path plan using that AB line. So I'm going to actually create another path plan. I'm going to add a custom AB line in here. And I'll shut off the slope. And so now this is with their exact run lines. So now I can build a path plan for my seeder or whatever using that exact run line right here. And then as we build other tools through this project, we can actually use their existing run lines. So we can take two scenarios. If the farmer's growing and they're buying a new farm, new paddocks, they can look at creating new run lines using the tool, or if with existing ones, we can build their path plans based on their existing run lines. So we have to be able to kind of accommodate both. So I'm going to just save this plan. So I guess what I was showing is these are a bunch of scenarios, right? They're just like scenarios with different kinds of outcomes. Maybe I have the least amount of soil loss. Maybe I have the best amount of the least amount of overlap, or maybe I have the least amount of time. It really depends on what the grower is actually looking for at that particular paddock. But let's just say that this is the one that they want. We can save that one right here. So one of the things that I've been doing in this is I've been using equipment where I have my track width and my tire width defined for everything that I've been doing. And this allows us to start looking at wheel traffic area two-dimensionally across the entire paddock. So every one of those path plans that I created and that I just saved, they're going to have wheel traffic area on them that we can calculate. So I'm going to just pull up one of these here. So this is this is the view of the save plan that we have. And this was 18-meter seeding, and we had a total wheel traffic area of 6.7 hectares across this field. So we're basically calculating that wheel traffic area for every one of these headland passes, and then we're starting to summarize that, and then as well as a percent of the field. For no particular reason, at least right now, other than we can do it, we also will show that. We can visualize that to the user. So these are all of their wheel tracks that we've summarized. We allow them to download that. We can kind of see some of our super users will start to play with those and provide us feedback on what we can do better, what new problems we can solve. So we've allowed them to download those as well. So that's the general summarizing of wheel track area for every, this can be done for every paddock at any kind of piece of equipment with tire spacing and tire width. I've kind of standardized things around 3 meter, but Vindy's helped me to kind of understand how those things are starting to change. Some of the old things aren't 3 meter, but we're also starting to see wider, correct? Due to bigger and bigger machinery. So one of the things that we're gonna work to help is understand what wider track spacing is going to do to their traffic area and how it works with the rest of their equipment fleet. Okay, so that's just a single path plan. That is a single independent operation. One of the concepts that we have, though, is that there is an interconnectivity between operations, right? You seed in a certain way because you're going to harvest in a certain way. If you're under full controlled traffic, all three or every single operation is very connected, and it's connected for a reason. In that case, it's really connected based on trying to minimize wheel traffic area. So even if you're not on controlled traffic, there's reasons. There's interoperational reasons why a grower might choose to do one thing or another. For me, here in soybeans, we harvest on an angle so that our cutting heads don't dull out. Everybody does it, right? There may be other scenarios where they farm something in a certain way because they spray every week and they hate doing that. So they'll have a much less efficient seeding operation because they want the most efficient spraying operation. Lots of interconnected decisions in there. And that's one of the things that we're working to basically connect. So there's farmer decisions for how I want to operate my equipment within a field, paddock. And then there's farmer decisions on why I do that affects another operation. So we have a feature called Plan From, and that's where we're going to actually create a plan based on another plan. So this could be one scenario. Could be I want to harvest 15 degrees off of all of my seeding operations. I want to create harvest operations that are at a 15-degree angle off, and I want to provide those to my operators. A very simple example. Yeah, you could tell your operators to do that, but you might get 15, you might not. So we're helping to kind of systematize that. But we've got a couple of different operations. So I'm going to start with my harvest operation here. This was a 12-meter front, and I want to create my seeding operation from that. And I want to, I have a couple of options here. I can do an inner row adjustment. So this is basically a translation. So this is when the scenario you might do is seeding one year to seeding the next year, where I want to be 15 centimeters off because I want to seed in between the rows. We have the track rotation example that I had. There's a couple different reasons why you might want to do that. Tillage reasons, for us harvest reasons. And then we have a reducing wheel traffic area, where we want to make an adjustment where we want to minimize wheel traffic area for that entire operation. And see here I already have my tire width and track width of my seeding operation. So I know the tires of my seeding, and I know my tires of my harvest already. And I can automatically create that plan, and then they're linked. So I've now linked those two plans. I know that my seeding plan was based off my harvest plan, and minimizing wheel traffic. That linking is something that we believe that will be very important, because basically that was another decision that just happened. Like, I wanted this to behave in that way. So what we have then is we have what we call seasonal plans. So this is a seasonal plan for a field. I have all of my operations planned out all ahead of time. And there's reasons I did every single one of those. And I want to just kind of open this seasonal plan up here. So in this case, my reference plan was harvest. And I wanted my reference plan to be harvest because it's my heaviest vehicle with my widest tire and my narrowest track spacing. So it's the one, it has the most wheel traffic of my operation. And then I wanted to align my seeding operation at 18 and my sprayer applicator at 36 to that. So I've minimized the wheel traffic for all of those. So each one of these I could go in here and view. I can see my wheel traffic here is 12.3 hectares. This one should be much less. I've got 3 skinny tires and a lot wider track spacing, so only 3 acres, or excuse me, 4 hectares of wheel traffic area. But what we can also do then is union these. Oops, I want to view. So here's my season. And we want to union all of those wheel traffic areas together. So now for all of those, I have 29 hectares of wheel traffic area over my entire paddock. So that is my trafficked area on that paddock for any machine. And basically the goal is I want to drive that down where I can. So we minimize that as much as possible given the equipment there. Obviously, if the seeder was a 12-meter seeder, we would reduce it even further because then you would have that perfect 3-to-1 ratio. But this is actually one of the scenarios that we're looking at with the project is, as seeders are getting bigger, what is the hit that I'm going to take on wheel traffic to go from 12 to 18-meter seeders? So I'm going to be more efficient, but I'm going to increase my wheel traffic area. And what's the benefit and drawback to that? And how can we help quantify that for growers? Right now, we're helping them calculate it and quantify it in the wheel traffic area and efficiency. But we're putting it onto them on what the weight of each one of those is for them. Might want to stop there because I'm going to move on to something slightly different. Any questions around what we're doing with path planning and wheel traffic area with the Australian growers? I'll get questions at the end too.
It's a lot to think about.
We'll do it once a week. You can join our session.
Hey Nick, I was just wondering, with the wheel traffic, and you've got like your 3-meter setup, is there potential where you can set up for like, say, seeding where you might have the tractor on 3 meters, but your seeder might be outside of that? Are you building that in? Because then you're going to get even obviously more wheel track coverage potentially.
Our data model, so this is I'm going to give you the good tech answer. Our data model supports that exactly. Our UI doesn't allow you to enter that complexity yet because it was hard. It was hard, and we wanted to keep it simple, and we haven't figured that out yet. But we can support many axles and duals and double duals. So we can support that. I could create a piece of equipment that did that for you. You just couldn't do that in our UI yet. But absolutely, we want to be able to do that.
Yep.
The other thing, because we also support. Today we're focused on just the main wheels of a seeder, but we could also support all of the other wings if we wanted to. But the assumption is that most of the weight is carried on those mains.
Yeah, it would get quite complex adding those extra wings.
But if we could automate that, if we could get those things from the manufacturers or somehow, like we can accommodate it, but we don't expect any normal human to be tolerant to enter all of that information. So we have to keep it simple and cover the 80%. But we can support it, yeah.
No, that's cool. Very, very good.
Okay. So the next piece here is I'm going to make another seeding plan with 2 headlines. One of the things that one of the problems that we've heard is, you know, large farms, a lot of operators, a lot of non-family staff, a lot of international, a lot of newcomers every year. And Vinny, I'm going to use no names, but I'm going to use the example of like some of the text messages that I've seen of farm managers trying to communicate how they want something done is just insane. So, you know, I want you to go over here and then go over here. And no, not that over there, right? And this is all in text. It's not graphical. But then they get out a map and then they draw on the map and then they send the map, right? And like it's very, very complex. And so the communication of what they want done when you have a grower or farm manager to the operator is an area that we're looking at solving as well. And to start, so we're basically starting to work on routing. So not just the plan that the piece of equipment executes with its guidance system, but actually how the operator maneuvers the equipment within that guidance plan. So, and this is probably not how it will look forever because it's a little busy. The red dot is the start, the end dot is the end. The arrows go from green to red, start to finish. So we're starting to describe where the operator will make that turn. Now, eventually, we would love to control that piece of equipment, but we're going to start with, hey, just show the operator where to go. The equipment has the path plan. It knows what to do when it's working, but what does it do when it's not working? What is it doing on any non-working maneuvering time, etc. So this is now a route where we're actually showing, we're going around every headland. One of the things that we don't have is a way for you to kind of mimic where that vehicle is going. We've got to build that. That will be very important. But you can basically tell that I'm going to start here and I'm going to work from north to south, and that's what we prescribe to do. So we're trying to give those farm managers the ability to basically say, this is how I want this done, operator, and then be able to deliver that to the operator. So the other piece to this is I'm going to save this path plan and I'm going to share it. And I'm going to fake that share here. So this is, think of this as my, what do I have here? An iPhone 14 Pro Max. I don't know what that is, but it's a phone. So this could go to the operator. Every operator's got a phone for now. I think every single person on earth, I think, has a smartphone except for my dad. And he does not. He has a flip phone. So operator's got this phone. Potentially, there's a bunch of paddocks in order. You typically order things. This is first to last. So I can go in to this paddock here. I want to potentially know that location. I'll talk to that in a second here. I'm not going to do that because it'll zoom me back into Sioux Falls. But we can then navigate for this operator. So we can start here and we can we actually reorient that map and then we navigate for them. And it gets kind of into a Google Maps type of view. When I asked to record the position, the intent is for to be able to give that information back to the farm operator on what actually happened. So this was what I asked for. This is what actually happened. Now, a lot of that stuff can be captured in Op Center and some Trimble stuff, but you know, not everything has that tracking capability. So they don't have to do that tracking part, but they can. But this is for the operator then. So if you think of the path plan, which is the headland passes and the tracks, that can actually go into a Gen 4 monitor and the machine can execute on that. But you also need something for the operator to execute when the machine's not working. So this is the operator. We call this operator guided routes. And this is just the first step on the line of routing. So, how can we help where the vehicles need to go, kind of. And this is like pre-autonomy, right? Like there's like 90% of autonomy in the machine today. So how can growers use what they have today, and get the most out of the automation that they have today? So I have an amazing guidance system in my machine, and now I have a path plan. I have a set of task instructions for my operator. Best I can hope for. I can record that. I can have a conversation with them. We can continuous improvement. How am I for time? I'm pretty much over. You got one more, Bindi?
Yep.
One more piece?
One more. Looks good.
Okay, one more piece.
Yeah.
It's
The
absolutely,
last. What's that?
it's absolutely fascinating.
Okay.
I can imagine
Good.
some of the farmers just really getting into this.
So the last piece is a slightly different. We built, this is called Equipment Explorer, and we really built this for dealers. But it can be, we built the tool for dealers, but the problem exists for everybody. And it's basically being able to compare equipment and land and other things on a macro level. So we want to compare things across an entire farm, hundreds, thousands of paddocks. I only have 4 here, but I could do 100. I could do 1,000. So this is one of the examples that we're looking at as part of the project. Bindi and Alice did some work on this, and one of the scenarios is I have I want to switch this around. I have a 12-meter seeder, and I'm looking at buying an 18-meter seeder. And I want to compare how section control technology will help me. So section control shuts off delivery of seed and fertilizer at smaller sections of the boom width that you have, so you have less and less overlap. So I want to compare what the grower has today with one section. So it's a 12-meter seeder. The full boom is putting down seed and fertilizer the whole way. I'm going to put them into an 18-meter seeder, and I'm going to have 3 sections. So now every 6 meters, I'm going to shut off a section. And I'm going to see how that affects overlap across my entire field. I'm also going to look at, they have, let's just say, some SF1 less than RTK accuracy on their GPS, 15 centimeters. And we're going to put them into SFRTK, which is a John Deere product, at 2 centimeters. And we're going to start to compare those things. I'm going to say there's $500 of input costs on a seeding operation, 500 AUD. I use some corn starter fertilizer and some seed corn, so I don't know how close that is, but it's not terrible. Anyway, I'm going to do this quick calculation here. So we're gonna create a path plan for every single field, and we're gonna do that for each piece of equipment, and then we're gonna provide a comparison for that user. And it really helps with technologies, so section control technology, etc. So overlap here. So on the grower's owned equipment, they have 169 hectares of overlap, product overlap across their farm. If they went to an 18-meter seeder with section control and RTK, they could drop that to 17 hectares. And if you're looking at $500 of input over 150 hectares, that's $75,000. So you can start to compare the the capital requirement to either buy new equipment or retrofit with new technology, and you can start to look at real values here on what that technology would do in improving their operation. Overlap it's a big problem, and there's 2 technologies there that help solve that: section control and GPS, and so that's a bit of a selling tool. Now, we did this for dealers. We made it really, really simple, but we see this being available for growers, for them to compare things across their farm. And that grower version of that would be much more Because if you're a grower that's looking at that stuff, you're willing to sit down because you're making $1 million purchase. You're going to sit down and spend more than 5 minutes. Whereas we made it super easy and simple for a dealer because they're only going to ever spend 5 minutes. They've only got 5 minutes with that grower. But you can kind of see where I want to compare 12-meter seeder to an 18-meter seeder, and I want to put real numbers to that across an entire farm of 100,000 hectares. A lot of calculations, and we can take away one of the reasons why we did this is that there's that objection in equipment. Well, that's not the way it works on my farm. I've heard a lot. You know, when nozzle control technology came out, you know, like there's X amount of savings. Well, that's not the way it works on my farm. I have rectangular fields. They're all rectangular. This allows the dealer to actually just be objective about it. This is how it would behave on your farm. So it kind of takes away that objection. So that's kind of my quick demonstration around Launchpad and how we're working to help Australian growers. Any questions from anybody? Any more questions, I guess?
Need to absorb more before I can ask questions.
It's fun. You can play around. If any of you are interested, if you go to vergeag.com, you can create an account and play around and just kind of get a quick understanding. I think it's 3 clicks to get a result to see a path plan. This, you know, look at this paddock is going to take 12 hours to complete. And these are the kind of inefficiencies that I might have.
I think Goddard's just put the link in the chat. So thanks, Nick. That's actually great to see how that's evolved. I haven't seen some of that wheel track area stuff. So it's actually cool to see how things have evolved from when we started first working with the user cases and then catching up with Nick and providing that feedback and then seeing the tools built. So yeah, that's great. It's looking good. I can't wait to go and play with it. Bit later today and next week with some of my case study growers.